Class number 2, daily summary. In this lesson, we explore two more voting methods, plurality with elimination and the method of pairwise comparisons. Number 1, our third voting method is the plurality with elimination method. It's also known as instant runoff voting or the Hare method. Voters fill out a preference ballot once. Round 1, if one candidate has a majority of first place votes, they have won and the election is over. Otherwise, eliminate the candidate with the least number of first place votes, thereby moving all candidates ranked below that candidate up one rank, and recount the number of first place votes. If one candidate has a majority of first place votes, they have won and the election is over. Round 3, eliminate the candidate with the least number of first place votes and repeat this process until one candidate has a majority of first place votes. Number 2. Let's use the plurality with elimination method on the math club election from last class. The preference schedule is given below. Round 1, tally the first place votes for each candidate. Let's begin there. So A, looking at first place votes only, that means we are in this row. First place votes, I can see A right here, but that's not just a single first place vote, that's actually 14 first place votes. So let's give A 14 first place votes here. Then we'll look for B, first place votes. So in this case, B is here only. So that's just 4 first place votes for B. Looking for C, C appears twice, there and there. That's 10 plus another 1, that's 11 first place votes for C. And then D, first place is only right here. So that's 8 first place votes for D. Okay, so we need to know if somebody has a majority, because if one candidate has a majority, then we stop the process. So let's count the number of voters altogether. So if we do the sum right here, 14 plus 10 plus 8 plus 4 plus 1, so I think that's 37. And if we're looking for majority, majority means more than half. So half of 37 is 18.5. More than half of 37 is 19 or better. So does a single candidate have a majority? Does anybody have 19 or more? And the answer is no. And so if nobody has a majority, then what we do is eliminate the candidate with the fewest number of first place votes. So that is candidate B in this case, which only had 4 first place votes. So what that means is that we are going to get rid of candidate B, and that means moving candidate B up, moving everybody below B up one rank. So first we're going to get rid of all the Bs. And then we're going to retally the first place votes. So first place votes is still this first row here. However, B did have some first place votes. And remember, everybody below B moves up a rank. So these 4 people right here that thought that B was the best, well, they have to give their points to somebody, but B is now out of contention, so they're going to give their points to whoever they thought was second best. So D just gained 4 points for first place votes once B has been eliminated. So it's everything in the first row, but if anybody in the first row has been eliminated, you got to move up somebody from below. Okay, so let us retally. So there is the short way to do this. Whoops, B is not there. There is a short way to do this, which is what I had said about D just gaining 4 votes. So you could just copy the numbers from before and give 4 more votes to D, but let's just go through the calculation again anyway. So first place votes for A, I only see 14 there. First place votes for C, that's there and there. 10 plus 1 is still 11. So we got 14 here, 11 here. D is the more interesting case. D had 8. But D now has another 4, and so that's 12 votes for D. And as a quick check, you can add up these 3 numbers here. 14 plus 11, that's 25, plus 12 is 37. It's still 37 because everybody who voted still has a voice in this election. Even those 4 people who thought B was the best, and now B is eliminated, they still have a preference. They still have a say. And so a real common wrong answer here is to keep this thing here at 8. And all of a sudden, we no longer have 37 voters represented. So that's another quick check we can use on this method, is to make sure that we still add up to the right total, which is 37 for this election. Okay, so then we ask the same question. Does anybody have a majority? Remember, majority was 19. Does anybody have 19 or more? The answer is no. And so in this case, we eliminate whoever has the fewest number of first place votes. That is candidate C, has only 11. Okay, so I'm actually going to do that in a different color. So we're going to get rid of candidate C. Okay, and now we have to recalculate first place votes. So I'm going to undo all the highlighting that we've got here. I think that eraser is too big for my purposes. Let's try this again. Okay, so we're going to get rid of all the highlighting stuff and then we'll re-highlight. So all that goes away. And remember, we were getting rid of all the appearances of C. So we'll cross off all these C's. And now I will re-highlight all the first place votes. So first place used to be in only the first row, but now in the column with the 10 voters, they thought C was the best, but C is out. They thought B was second best, but B had already been eliminated. So these 10 voters, again, they still have a say. Their next best choice of all the candidates who are still eligible is D. So D just got some more first place votes. First place up there, first place there, first place there. And now we calculate first place votes. Okay, so A has 14 in the first column, and that's it. That means that everybody else thinks that D is the next best available candidate. So that's 10 votes plus 8 plus 4 plus 5. So that's 18, 22, 23 votes right there. And again, we can do our check by adding up those numbers, 14 plus 23. Oh, good, that's still 37. That's what it's supposed to be. Do we have a majority candidate now? Yes, we do, because majority was 19, and we now have somebody that has at least 19. So in this case, D wins. Okay, number 3, let's list the complete ranking of the candidates using the plurality with elimination. Okay, so we've already discovered clearly D is in first place. So of the remaining candidates, who makes the most sense to give second place to? Well, I guess it's whoever was in the final round with D, right? And that was A. So A didn't win this thing, but A lasted longer than everybody except for the winner, which was D. So it seems only fair to call A the second place candidate. And then if we go one round earlier, we've already got C and D ranked, but already got A and D ranked, but C was eliminated there. So it seems fair to say that C should be our third place candidate, and then our last place candidate would be whoever was eliminated first, and that was B. So B comes in last in this election. So there's our ranking, DACB. Okay, next page. 4, let's write down the winner of the math club election using each of our 3 vote counting methods. We did 2 of these methods last class, so you can go check, but we discovered last class that the plurality winner was A, the Bordeaux winner was C, and then the brand new method, the plurality with elimination, is D. Again, perhaps a frightening result that exactly the same election had 3 completely different winners depending on how we counted the votes. Number 5, our 4th election method is called the method of pairwise comparisons, sometimes called Copeland's method. Each voter fills out a preference ballot just once, and as the name suggests, we compare every pair of candidates. For each head-to-head comparison, the winning candidate gets 1 point and the losing candidate gets 0 points. They each get half a point if there's a tie. All of the points are tallied up, and the candidate with the most points is declared the winner. Here's the Math Club preference schedule yet again. Part A, how many voters were there in total? Well, we've done this already, but we'll just do it again here. That's 14 plus 10 plus 8 plus 4 plus 1, which is still 37. Let's determine the election of Math Club president using this new method of pairwise comparisons. We begin by listing all of the possible matchups. So, for example, we could have A versus B, or A versus C, or A versus D. Those are all the head-to-head matchups involving A. So let's move on to the ones involving B. Now, you could say B versus A, but we've already calculated that. We've already done that head-to-head matchup. So we're looking for unique head-to-head matchups that we haven't already written down here. So not B versus A, because that's already written, but B versus C. and then B versus D. And that's all the new head-to-heads with B. And then let's move on to C. So C versus A, we've already got. C versus B, we've already got. So only one left for C is C versus D. And then moving on to the D matchups, D versus A, we've seen that. D versus B, we've seen that. And D versus C, we've seen that. So that is a list of all of the possible matchups. There are 6 of them. Okay, so let's start doing the calculations here. We are looking for A versus B. So let's look in the first column right here. A or B. I'm going to highlight actually all of the A's in yellow. And then I'm going to highlight all the B's in blue. Okay, and I'm not going to pay any attention to C's or D's for the purpose of this head-to-head matchup. It's only A versus B. Okay, so let's look at the first 14 people. Out of A or B, who did they prefer? Well, they preferred A. So A just got 14 points. Let's look at the next group of people. We've got 10 people. Who did they prefer? Well, okay, their top choice was C, but C is not part of this particular head-to-head matchup. So C is not in the discussion. So only between A and B, who did these 10 people prefer? Well, they preferred B because B is above A. It makes no difference what positions these two are in. Happens to be second and fourth. All we care about is who is higher. And so in this case, 10 people think that B is better. Let's look at these 8 people right here. Between A and B, they think B is better. Let's look at these 4 people. All right, they really have a strong preference for B over A because they thought B was the best and A was the worst. But again, doesn't matter. All we need to know is who is above. So B gets those 4. And then finally, this one person over here, to be honest, didn't look like they thought much of either A or B, but when push came to shove, they thought B was better than A. And so actually all of these people right up here thought that B was better than A. And so we get to add all of these votes and give them to B. So 10 plus 8 is 18, plus 4 is 22, plus 1 is 23. And again, another quick check here is to make sure that the total is the total number of voters. 14 plus 23, yep, that's 37. Real common wrong answer that I see here is for people to say, oh, okay, A got 14 votes there, B got only 4 first place votes here, and so they will just put 4 there. That's not a head-to-head, that's plurality counting. If you're only looking at first place votes, you're not doing head-to-head. Every one of our 37 voters gets a say in this election. So got to make sure that the totals always add up to 23. Okay, let's keep on trucking here. Start moving a little bit quicker. Let's start by looking at the next matchup, which is A versus C. So this first group of 14, A or C, well, they think that A is the best, so we're going to give A 14 votes right there. Looking at the next group of 10, A or C. All right, C is above. A or C, C is above. A or C, C is above. A or C, C is above. Okay, so that means that again, all of these people think C is better than A. So 10 plus 8 plus 4 plus 1, that is also 23. And then finally looking at the A versus D matchup here. These 14 people think that A is better than D. These 10 people think that D is above. 8 people think D is above. 4 people think D is above, and 1 person thinks D is above. So that is another loss for A. That is 14 to 23 yet again. Things will get a little bit more interesting now that we're done with A. The reason that A only got 14 every single time is that everybody else besides those 14 people in the first column thought A was the worst. And so A lost every other head-to-head matchup by the same exact score, 14 to 23. Okay, but we'll get a different score here for B versus C. Okay, let's give this a shot. B versus C. In this first column, 14 people, they thought that B was the best. In the next column, I'm just going to check the ones that thought B was the best. So in the next column, the 10 people, B or C, they thought C was better. That's right there. In the next column, B or C, they thought that C was better. In the next column, right here, B or C, they thought that B was better. I'm going to give B those votes. And then the last column, B or C, they thought C was better. So just looking at my check marks, which was only for B, I see 14 and 4, that's 18. So B just got 18 of those. And that means that all the other columns were won by C. So that's 10 and 8 and 1, that's 19. Again, a quick check, 18 plus 19, That's 37, that's correct. So C won that head-to-head matchup, just barely, but they won it. Okay, and then we'll move on to B versus D. Again, I'll arbitrarily check off anytime B wins. Okay, so B or D in the first column, that's a B. B or D in the next column, that's a B. B or D in the next column, okay, that's not B. D wins that one. B or D here, that's B. And then B or D here, that's D. So I only checked off the ones that B wins. So 14 and 10 and 4, that's 28. And then finally, D gets all the other columns that aren't checked. 8 and 1 is 9. And again, add those guys up. 28 plus 9, that's 37. Great. And then finally, C versus D, I will arbitrarily decide to check off the C's. So C or D here, that's C. C or D here, that's C. C or D here, that's D. I'm not going to check that. C or D there, that's D. I'm not checking that one. C or D here, that's C. I'll check that one. So the checks for C's, 14 plus 10 plus 1, that's 25. And then every other column for D, that's 8 and 4, that's 12. Add up 25 plus 12, again, we get our magic 37. Okay, and now we just have to give points. So remember, every head-to-head matchup is won by somebody. So in this very first matchup right here, we've got A versus B. So B wins that one, 23 to 14. So I'm just going to circle the winner in each head-to-head. Moving down, A versus C, that was won by C, 23 to 14. A versus D was won by D, also 23 to 14. B versus C, that was our closest one, but C just squeaked out a victory, 19-18. B versus D, that wasn't all that close. Whoops. B wins that one, 28 to 9 right there. And then finally the last one, C versus D, C wins 25 to 12. And so now we just have to award points. A, and B, and C, and D. So counting up the number of points that each candidate gets. Okay, A did not get circled a single time. A just got 0 points. How many times did B win? I see B circled twice, 1 point each. That gives 2 points for B. C is circled 3 times, 1 point each. That's 3 points. And D is circled only once, 1 point for that victory. Again, if there had been a tie in any of these, which wouldn't be possible with an odd number, 37 voters, if it's a tie, then each candidate would get half of a point for that particular head-to-head matchup. Okay, and so we've got our winner here with the most number of points here is C, 3 points. Let's see here. So I think we're down here in part 7. It says, who is the winner using the method of pairwise comparisons? So that's C with 3 points. And then the complete ranking, let's see, okay, so C had the most number of points, and then after C, the next most number of points is B. B got 2 points, and after that, D got 1 point, and dead last is A with no points. So the order here for the ranking is C, B, D, A. C, B, D, and then A. Next page. One downside to the method of pairwise comparisons, this method can lead to a lot of ties, sometimes many candidates tie for the most points, and every new candidate adds a lot of comparing that we have to do. If there are n candidates, this simple formula tells us how many comparisons we'll have to do. Number of comparisons equals n times the quantity n minus 1, all divided by 2. Again, n is the number of candidates. So for example, in our case, the last selection that we did, we got it right here in part A, we got 4 candidates. Okay, so in this case, n is 4, so we're just plugging n equals 4 into our brand new formula. So 4 times 4 minus 1 over 2. So again, that's just replacing both ends with 4 candidates, A, B, C, D. And then we do our calculation, 4 times 3 over 2, that's 12 over 2, which is 6. 6 comparisons, 6 head-to-head comparisons. And that's exactly how many comparisons we just did. A versus B, A versus C, A versus D, B versus C, B versus D, and finally C versus D. 6 different comparisons. But what if there were 10 candidates? Okay, let's use the spiffy formula for this one. 10 times 10 minus 1 over 2. 10 times 9 over 2, 90 over 2 is 45 head-to-head comparisons. Okay, we just did 6 head-to-head comparisons. It took us a little bit. In a 10 candidate race, you'd have to do 45 head-to-head comparisons. That said, this isn't something that needs to be done by humans. It's be quite easy to write a computer program that would churn through those 45 comparisons very quickly. Number 8, in case you're interested in seeing a real-life preference ballot, below you'll find an image of part of an actual ballot from a Burlington, Vermont mayoral election. Note that Burlington used plurality with elimination, that was the first method we saw today, for a couple of elections, but the city voted to go back to using the plurality method. So here's the ballot. And just in terms of logistics, so that you see it's not all that complicated to rank the ballots and create your own preference ballot. You can rank your first choice. You can say, okay, I think this candidate is the first choice, and the second candidate will go right here, and the third candidate will say, is this person up here? And you just fill in. And it's not all that hard, and you can see it's a computer ballot. It can be read very quickly by a scanner, and that scanner can then interpret the results and like I said, just have a computer program that will churn through all of the comparisons or whatever method you're using. Can be done pretty quickly once the infrastructure is in place.